we're going to take a couple minutes here and look at some homework problems. So this is from section 1.5. It's the first part that we worked on with our power properties. So first, it's really important that you do know your power properties. You want to make sure that maybe you have them on a note card or somewhere to reference. So I'm going to pull out a quick note card that I have. And I think this is really helpful. So let's just do a quick recap of our rules. What I like about this note card, I call it a note card, but this sort of cheat sheet, is they also give you an example. So when you look at this and you have multiplication of the bases, you add the powers. And so the example b to the second times b to the fourth is really going to be b to the sixth because we add 2 plus 4. And then we're looking at y. B squared, there's 2 of them there. B to the fourth, we multiply 4 times, and that's why we have b multiplied out 6 times. All right, if we have division and they have to have the same bases, then we subtract. So that makes sense. With longhand multiplication, we add. With longhand division, we subtract. So when we divide the same base, we subtract the powers. And so here we would have the numerator minus the denominator. So b to the fifth minus 2. And we find that difference. Now, sometimes when you're subtracting, you're going to get a negative difference. And so we have to talk about a negative exponent. The other thing that you can consider when you have a fraction like this is canceling them. I have 5 b's on top, 2 on the bottom, and so if we cancel one of each in sets, then we're left with 3 b's on top. We can also do that right from here, where we knock out 2 and knock out 2, b to the third is left. Be careful if it's left on the top or the bottom. All right, then we have our power rule. A power to a power is what it looks like. B to the m power of n is b to the m times n. So anytime you have a power to power, you're multiplying. And so here we have b to the fourth to the second. So if you can look at these are the two that people mix up. B to the fourth to the second is very different than b to the second times b to the fourth. So when I multiply the bases, I have 2 of them here and 4 of them here. I'm multiplying b 6 times, thus b to the 6. Here, I have a power to power. The rule is to multiply. So if we look at y, if I have b to the fourth squared, that means I would have b to the fourth right here times b to the fourth. And now I have 8 b's altogether. All right. Power of a product. So here I have multiplication, and I have a power of m. It's almost like we're distributing it, okay? Just like we do with the square root of ab, it's the square root of a times the square root of b. It's very much this problem because roots and powers are inverses. So I have a times b to the third. As long as it's multiplication, you can distribute that power to everything inside. And why does that work? Well, if I have ab to the third, that means I'm going to have ab multiplied out 3 times. If we write it out, I have 3 a's. We use our commutative and associative property. I have 3 a's and I have 3 b's. A to the third, b to the third. Same idea when we have division. I keep my bases are different here, okay? So I keep the numerator, I keep the denominator, but I give each power. Same as the roots. When I had the square root of ab, I had the square root of a over the square root of b. So same rules as our roots. So here's an example. A over b to the third is the same as a to the third over b to the third. If we write that out, a to the third, or a over b 3 times, we have a to the third and b to the third. Okay, 2 more rules down here. If I have b to the 0, if I have anything to the 0, I always get 1. And most people, when I say what's for the 0, tell me it's 0. So remember, anything raised to the power of 0 is 1. You can always double check that in a calculator if you forget. If I have a negative exponent, I know it's hard to see, but that's b to the negative n. That negative exponent is not a negative number. It's telling you to take the reciprocal, okay? So we are taking and inverting our fraction. So that's b over 1 becomes 1 over b, and notice the power is now positive. So when you take the inverse, or sorry, the reciprocal of your fraction, your power becomes positive. So the negative exponent only says to take the reciprocal. And then I'd have 1 to the n, which would stay as 1, and then b to the n. So once I flip it, I'm really coming back and using that property up here, power of a quotient. If I have b to the negative 5, you can see it's 1 over b to the power of positive 5. So once you flip the fraction, you have a now positive power. Eventually we're going to talk about function notation, and you'll see that f to the negative 1 represents an inverse, which sort of comes back to this. Okay, the only other rule that's not on here is if I have a fraction like a over b to the power of negative m, I would flip the a over b to make it b over a. So I can always take this and put it in the bottom. If it was a negative power, I'd put it back in the top. So you're always going to flip it. So I just want to do a quick review of these. It took us 4.5 minutes to talk through these. I really think transferring these rules to a note card, not worried about the names, I'm worried about the rules and some examples, that's good. So this would be a good spot to pause this recording. Let me put this up here. Be a good spot to pause this recording, and all these rules are in one spot. Maybe you transfer them. Okay, so let's go ahead and talk about these homework problems now that we went back and reviewed that. So I picked some problems out that I thought might be something we want to review, and I thought this might be helpful before you move on to the next worksheet. So I have 12xy all in parentheses to the power of 4, and the directions on number 3 said to write it in expanded form. So expanded form, I would actually write out 12xy 4 times. 12xy, 12xy, and one more. And that's all I had to do. It didn't ask to simplify it, it just said write it in expanded form. Alright? Otherwise, I could distribute this and make it 12 to the 4th, x to the 4th, and y to the 4th using my properties. But they want it expanded. Okay, so then we come to number 23. I jumped a little bit. It says to write this expanded form. I want you to check what you thought about doing here. A lot of people want to write 5x 3 times. But it's really a 5 and then x times itself 3 times. So the 5 has a power of 1 there. If it was written as 5x quantity 3, then we'd have 5x times 5x times 5x. So very different idea. This is our answer here. Okay, with our power properties come the order of operations. So if you think about that, please excuse my dear Aunt Sally or PEMDAS. We start with what's in parentheses. In my parentheses, there's actually nothing to do. I have mn squared. So there's nothing to do or clean up in parentheses. Next, I'm going to do exponents. So I have n squared. There's nothing to do there. But here I have a power to power. So I'm using 2 of my rules here. I'm going to keep that negative 4m. I don't want to lose it. And I'm going to distribute this power to everything inside. Now that's m to the 1st. So a power to power we multiply, and that becomes m to the 3rd. And that's n to the 2nd to the 3rd. And again, a power to power we multiply, so n to the 6th. Now I'm not done yet. I've done my exponent, and now I need to multiply and divide in order from left to right. So these parentheses here were just for grouping for that power. Now they just mean multiplication. So you're going to go through and you're always going to clean it up. Clean up your numbers, clean up your variables. There's m to the 1st there, there's m to the 3rd there. So I'm multiplying like bases. I keep the base, I add the powers. Remember, there's 1m there, there's 3 more. So I'd be multiplying it out 4 times. And then the n to the 6 just comes along. And that's my final answer. Okay. Next one, we now have some negative exponents. So notice that y is in 2 places and x is in 2 places. Whenever you simplify with exponents, you want to make sure each variable only shows up 1 place. You want to make sure you have no negative exponents. All right? So first thing I like to do, the rule is to take the numerator minus the denominator. So if I do x to the negative 1 minus 3, I'm going to get x to the negative 4th. And that's fine, I just have to deal with it later. But this is where people mess up if they try to follow the rule. Let me grab a piece of paper here. So this is what I was talking about. Some people will do this as x to the negative 4th because they take x to the negative 1 minus 3. And then, so that's x to the negative 1 minus 3. Gives me the x to the negative 4th. Times, and then they do this, y to the negative 2nd, but it's minus a negative 5. So if you did that, would you catch that negative sign and make it y to the 3rd? So I can do it this way, and then I see that negative 4 and it comes down. And so that leaves me y to the 3rd over x to the positive 4. A negative exponent takes the reciprocal, becomes a positive exponent. This we get a lot of mistakes here. So rather than subtracting, we're going to move things. You also cannot cancel. I can't take one of these and one of these because that's a negative 1. So the first thing I like to do is just anything that has a negative power, I'm going to move it. So this 3 stays. X to the third stays. Don't just flip it. So this is going to come down. So I'm going to build my fraction, because building a fraction keeps things in the right place. X to the third was down here, and I brought x to the first down. So we can clean that up here in a minute. Y to the second's negative, so it's going to come down and be y to the second, and y to the negative fifth is going to move up. Okay, so negative exponents move from numerator to denominator and vice versa. X to the third stays. Don't flip that anywhere. Now let's clean this up. I have 2 x's down here, x to the first, x to the third, add the powers. And then the y's we could subtract, or 2 goes out of here, there's 3 left on top. And there's that same answer, y to the third, x to the fourth. Okay, now number 39 is a different type of problem, but it's something we should be able to do. So even if you weren't sure what they meant by write them with a base of 2, I can understand if that was sort of out of your element. But least to greatest, everyone should be able to do that, okay? So you could type it in a calculator, 8 squared is 64, that's 4 the first. You could find out what each number is pretty easily and put them in order. And again, whenever you put something in order, you always give it back the way the problem was given. They want us to write it with a base of 2. So I need you to think about some of your properties a little bit harder than you might have already. I still have something squared, but instead of having an 8, I'm going to write it as 2 to the third. So this is me asking you to change how you thought of it. You might never have thought to do it this way. So here's a new way to look at it. So again, it's 2 to the third. That's the same as 8. So that's all I did. And then I keep the base, and a power I multiply, which is 6. Okay, 4 to the first. That's fine. We're going to rewrite 4 as a base of 2. So 2 squared. Power to power we multiply, so that gives me 2 squared. All right, 2 to the fifth, don't have to do any work there. And then 16 to the negative second. Well, that would be, we got to think about this. Keep my negative 2 up there. I'd have 2 to what power to give me 16? Okay, and it's 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. You have to think that out. And a power to power we multiply. So I'd have 2 to the negative 8. Now, I just told you how we don't leave negative exponents, but they asked us to write this as a base of 2. So I'm going to leave this alone. I'm not going to flip it. Now, if I have to put them in order from least to greatest, I can really see now that if a power of negative 8 is my smallest number, so 16 to the negative second is the smallest number. Then a power of 2, then a power of 5, and then a power of 6. Oh, I just did that wrong. Let me back that up. Try again. All right, so next in line after the negative 8 was 2 squared, which was 4 to the first. I was just saying how you give it back as the answer. So 4 to the first. Okay, 2 to the fifth, that one I could have left. And then the last was 2 to the sixth, which came from 8 squared. Okay, so these were the 2 parts of your answers. Base 2 and least to greatest. There you go. Okay, I want to show you something real quick. If I type in 2, let me try to get a better angle on here, 2 to the negative 8, I get a really small number, 0.0039, and then it goes on a little bit more. Okay, so tenths, hundredths, thousandths. I get almost 4 thousandths. So if you think about 2 to the negative 8, that is the same, just to extend this, 2 to the negative 8 is the same as 1 over 2 to the 8th. Now, I don't really know what 2 to the 8th is offhand, so I'm going to go ahead and do 2 just to the 8th. And it is 256. 2 to the 8th is 1 over 256. And if I take 1 divided by 256, I get that same decimal. Okay? So that's how a negative exponent works. A negative exponent takes the reciprocal, then it builds it, and so we're going to get that number between 0 and 1 if I have a positive number. Okay, so here's 49, another power property problem. And so we're going to still do that order of operations. We always want to go back to that. So in my order of operations, I want to do what's in the parentheses first. So I'm going to let this sit here, because the more I can clean up in here, the better it is. Now there's not a lot going on, but if there were lots of things going on, I would try to cancel it. I want to get my numbers reduced. I want to get my variables broken down so I only have one of each. In these parentheses, the m cancels out, and so I'm left with 5n over negative 3m, all still to the power of negative 2. Now, before I distribute this, I really don't want to distribute a negative power, because a negative power means I'm going to have to flip it. So instead of distributing it, I want to deal with the negative sign first. And so that's going to leave me negative 3m over 5n, all to the power of positive 2. So again, none of that changed. The negative power only flipped everything inside. And now I'll distribute that too. Now don't forget, it has to go to everything, including that negative sign. So a negative number squared is going to be positive, right? Negative 3 times negative 3, I get positive 9, and then m to the second. In the bottom, I put it to the 5 and the n, so 5 squared is 25, and then n to the second. So always double check about reducing your fraction. Always double check that you have positive exponents and the variables only show up one time each. All right. That's it for the power properties. I thought maybe we would go over these last two. It might be easier than you realized. So they asked for the number of square inches in a square yard. So I don't know how many square inches in a square yard. I'd have to figure it out. I'd have to think for a quick second about how many inches were in a yard, which is 36, okay? But let's say we didn't know that right off the top of our head. Most of us know that there are 12 inches in 1 foot. And then we know that every 1 yard is equal to 3 feet. So if you can picture having something and we break it into 3, let's extend that. We break it into 3, 1 foot, 1 foot, 1 foot is giving me 1 yard, okay? And then in each foot we get what? 12 inches. So there's your conversion. 1 yard is equivalent to 3 feet, and each foot is equivalent to 12 inches. So 12 times 3, we have that 1 yard is equal to 36 inches. Now that's just for length, okay? That's just the distance. They want to know how many square inches are in a square yard. So now imagine squaring this off. This again is 1 yard, which is also 36 inches. So to find the area, wouldn't you take 36 times 36, and that'd be what you get in inches. So 1 yard times 1 yard would be 1 yard squared. 36 times 36 for the length, and times the length of my square would be 36 inches squared. And so I'd use a calculator. 36 times 36 ends up being 1,296 inches squared. So imagine gridding this off, 12 going down, 12 going across, and then do that 12 here, 12 here. We'd end up with 36 inches going here times 36 going here. We'd end up with 1,296 inches squared. Okay, so a very similar problem. Number of cubics. So now we're talking about volume, okay? Number of cubic inches in a cubic foot. So we know 12 inches is equal to 1 foot. Okay, now let's picture a cube here, right? This is as good as it's going to get. Got my cube here, and I know that this is 12 feet. Oh no, not 12 feet, 12 inches. This is 12 inches, and that's 12 inches, and that's 12 inches, because it's a cube, right? We're talking about cubes. And so on a cube, all my sides are the same. So this is like the length, the width, and the height. And we're talking about cubic inches, that's volume. And volume is length times width times height. It's that third dimension. When you do length times width, you're finding the area of the base, and then you multiply by that third dimension height coming out at you. So we'd find the area of this base right in here, and then we'd multiply by the height. And so when you're talking about this, picture this being cut up into 12 by 12, we'd see how many little blocks are in here, okay? So 12 times 12 times 12 is 12 inches cubed. And 12 inches cubed is 1,728 cubic inches. And 1 foot cubed, if we look at this as 1 by 1 by 1, stays 1 foot cubed. And that's the answer. 1,728 inches squared. So I don't think that that was hard. We just had to think a little bit differently. So picture those little sugar cubes. Picture all of those being stacked up in here. Okay, pretend they're 1 inch by 1 inch by 1 inch, and that's how many you would have in 1 cubic foot. Think about how big a foot is. So that's a very small little blocks to have 1,728 inches cubed. Okay, well, I really need to make sure that you're practicing your power properties. I'm going to end this video, but continue working. I hope this helped to go over some of your homework questions.